Hey everyone, we're going to continue on with our limit boot camp today. So we're going to take a look at evaluating limits from graphs. All right, so we said we were going to do some more with limits. We're going to just take a look evaluating limits graphically. Quick refreshers. We had said in our last lesson and even way before in the beginning of the year, remember that y is a function of x, so that meant y and f of x were interchangeable with each other. So when we're taking the limit of a function, you are actually looking at what's happening to the y values as you approach the indicated x value. So you will typically see it as the limit of f of x as x goes to something. So we just have infinity down there. What we're really asking about, what we're really referring to, is what is happening to the y values. So you'll probably never ever see it as the limit of y, but we are looking at the y values. What are the y values doing? That's what limit is referring to, the y values. So we could have limits from the left and limits from the right of a certain x value. So when you see something written with a little down below the limit, x arrow 0, and then a little negative symbol where an exponent would be, that is read as a limit of f of x as x goes to 0 from the left. If you see a little positive or a little plus symbol where an exponent would be, that's the limit of f of x as x goes to 0 from the right. Graphically, when you're trying to evaluate those, you're just looking again at what is the y value approaching as you get closer to the indicated x value. Overall, the limit could exist at a point if the limit from the left is equal to the limit from the right. Algebraically, it's written right here. The limit of f of x as x goes to -4 is going to exist if the limit of f of x as x goes to -4 from the left is equal to the limit of f of x as x goes to -4 from the right. So that was written algebraically. Graphically, how would we determine if that limit's going to exist? If we were taking a finger from each hand and tracing, getting closer to that indicated x value, if our fingers actually meet as we get closer and closer and closer to x equals -4, then that limit is going to exist, and then the y values where our fingers met is going to be the value of that limit. So we are ready to start our basic training right here. Funky looking graph, and then a whole bunch of limits that we need to evaluate. Here we go. All right, so here's our graph. And what is up first? We have the limit of f of x as x goes to -infinity. As x goes to -infinity, we kind of did those questions in one of our last lessons, I think. As x goes to -infinity, that means we're going all the way over to the left. All right, all the way over to the left, 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 right, left. Okay, bad joke. But okay, look at go and then take a look all the way over on the left-hand side of the graph. All the way over on the left-hand side of the graph, this graph is going up, and it's not going to stop going up. So we can say that the limit of f of x as x goes to -infinity, that one we can say there is infinity. All right, and what do we have next? The limit of f of x as x goes to 1 from the left. All right, as x goes to 1 from the left. So here is x equals 1. Here's x equals 1. We're going to come at that 1 from the left. All right, so as we come at it from the left, we're tracing along here. And then we get really close to this value here, which looks to be between 3 and 4. So that's going to be 3.5. Okay. Then next, limit of f of x as x goes to 1 from the right. So again, we're back here at x equals 1. Now we're going to come at this value of x equals 1 from the right-hand side. So we're tracing along here. As we do that, we're getting really close to this y value right here, which is the number 1. So that limit is equal to 1. All right, then overall we want to try to find the limit of f of x as x goes to 1. So that means we don't have a little positive or negative where an exponent would be, so that means we want the limit from both sides. So let's trace from both sides and see what happens to our fingers. As we trace from both sides, my fingers did not come together. All right, my fingers did not come together. I have one up here and one down here. That means that this limit does not exist. And then this bottom one is not a limit, but then it's just asking us to determine the value of the function at x equals 1. So over here, x equals 1, we have three circles, an open circle, a filled in circle, and another open circle. That filled in circle represents the value of the function at that x value. And right there, that is 2. All right, when we see these graphs, this graph is made up of more than one piece, so it's coming from what's called a piecewise defined function, made up of 1, 2, 3 pieces, all right, piecewise, multiple pieces. If, again, we're dealing with a function right here at the x value, right here at that x value of 1, if we had drawn a vertical line right here, it would have gone through all of those circles. All right, but we learned way back in chapter 1 that to be a function, you had to pass the vertical line test, which means that a vertical line could only cross the graph once and only once. So when you see circles on top of each other in a line, only one of them will be allowed to be filled in, otherwise it would fail our vertical line test. Alright, so now we're moving over to 4. Alright, we want the limit of f of x as x goes to 4, little negative symbol, so from the left. Alright, 1, 2, 3, 4. So here's x equals 4. As we get really close to x equaling 4, really close. So we get doing something crazy over here, but we really only care about what happens as we get really close to x equals 4 from the left. So as we get really close to x equals 4 from the left, right, we're coming along right here. We're getting really close to that y value of 2. All right, limit of f of x as x goes to 4 from the right. 1, 2, 3, 4. So again, we're back over here. We're getting really close to 4 from the right. We're getting back to that same y value of 2. This time we do not have a little additional, a little positive or negative symbol where an exponent would be. So we're talking about the limit from both sides. So here we go, let's trace from both sides, and when we do that, our fingers do meet together. All right, our fingers do come together right there. All right, our fingers do come together. They came together, they met at that y value of 2. All right, that agreed with what we had written algebraically in our notes. The limit from the left was equal to 2, the limit from the right was equal to 2, so overall the limit was equal to 2. With this last one, the limit from the left was 3.5, the limit from the right was 1. 3.5 and 1 are not equal to each other, so overall that limit did not exist. All right, this one, evaluate the function at 4. At 4, we have a hole. All right, so this function is not defined. All right, the function does not exist. All right, you could say the function does not exist at x equals 4, or it's just undefined. All right, so you could say either does not exist or it's undefined. And that's okay, all right? So yes, even though we did say our fingers were coming together, they never truly met because there was that hole there, but they were getting infinitely close to each other, so close. So because they were so close, the limit of the value that they were getting to did actually equal 2, all right? The limit was equal to 2, all right? They were getting so close together that the limit was equal to 2. And this last one here, the limit of the function as x goes to infinity. As x goes to infinity means we're talking about all the way over on the right side of the graph. Right, as we go all the way along to the right side of the graph, that looks like it's going to creep up ever so slightly. All right, looks like it's going to creep up ever so slightly, so eventually it's going to get all the way up there so big that we could just call it infinity. All right, let's take a look at another one. All right, so we've got another crazy graph, another piecewise function broken up into more than one piece, and then we need to take a look at what's happening at -2, 0, 2, and 4. All right, so we drew our graph, and then here is everything we need to take a look at. So we're going first from -2. All right, the limit of the function as x goes to -2 from the left. All right, so here's -2. All right, as we get close to -2 from the left, this graph is going down. It's not going to stop going down, so that limit is going to be -infinity. Then we're going to take a look at the limit of f of x as x goes to negative 2 from the right. So again, it's doing a lot of crazy stuff over here. We really only care about what happens when we get really close to x equals negative 2 from the right. All right, so here again is our negative 2. When we get really close to negative 2 from the right, the graph starts going up, and it doesn't look like it's going to stop. So that's going to infinity. All right, let's try to do this one just from looking at the limits instead of looking at the graph. We want to look at the limit of f of x as x goes to negative 2. That meant that the limit from the left had to equal the limit from the right. The left limit was negative infinity. The right limit was positive infinity. Those are not equal to each other. So that means that this limit will not exist. All right, we can go back and double check with our graph. All right, again, here's negative 2. Let's have our fingers get really close to, or see what happens as we get close to x equals negative 2. I have one going down and one going up. My fingers have not met, so again, that limit does not exist. What is f of 2? I don't see a dot, and I don't know because this is going all the way up and this is going all the way down. So f of 2, undefined, does not exist. All right. Then let's move over to 0. Take a look at what's happening at 0. Take a look at the function as x goes to 0 from the left. 0, here's 0. 0 from the left. As we trace along from the left, it looks like we're getting really, really, really close to that y value of 1/2. And let's take a look at the limit of the function as x goes to 0 from the right. So here's x equals 0. Again, we really only want to care about what happens when we get really close to x equals 0. So as we're doing that from the right-hand side, we're going up. We're getting really close to that y value of 4. The limit of f of x as x goes to 0. So we could again try to do it just from looking at these two limits. The limit from the left was 1/2. The limit from the right was 4. 1/2 and 4 are not equal to each other. So this limit does not exist. Again, graphically, all right, as we get close to x equals 0 from both sides, my fingers have not met. All right, my fingers have not met. That limit does not exist. What is f of 0? Again, here is x equals 0. Here's x equals 0. Here's an open circle, so it's not that. Here's a closed circle, so it must be this value here. All right, and let's move over to 2. Let's move over to 2. Here's 2. We want the limit of f of x as x goes to 2 from the left. All right, as we go really close to x equaling 2 from the left, we're getting really close to that y value of positive 1/2. Let's take a look at the limit of the function as x goes to 2 from the right. All right, as we get really close to x equaling 2 from the right, we're again getting really close to that y value of 1/2. All right, overall, if we want the limit of f of x as x goes to 2, that would mean the left limit equal the right limit. Left limit is 1/2. The right limit is also 1/2. So the limit as x goes to 2 is 1/2. Graphically, our fingers come together. All right, graphically, our fingers come together. They do, let's see here. That's actually part of that next part. What is f of 2? There's an open circle there, so that means that f of 2 does not exist. All right, so our fingers come together. They will not ever truly meet, but they'll get infinitely close to each other. All right, so the limit as to how close they could get is infinite. All right, we could get so small, they would just get closer and closer and closer and closer and closer to each other. So that limit is equal to that 1/2. Let's move over to 4. X equals 4. The limit of f of x as x goes to 4 from the left. 1, 2, 3, 4. All right, 4 from the left. As x goes to 4 from the left, we're going up. It looks like we're not going to stop. So that's infinity. As x goes to 4 from the right, we're going up. Looks like we're not going to stop. So that's also infinity. And the limit of f of x from both sides as x goes to 4. The limit from the left was equal to infinity. The limit from the right was equal to infinity. So this one should also equal infinity. All right, if we traced, yep, our fingers are both going up in the same direction. All right, f of 4, The function, although a limit can equal infinity, a function can actually never equal infinity. But we also do have, let's see here, at 1, 2, 3, 4, we do have this blue dot in here. All right, so we do have this blue dot in here. So that is telling us right there that the function is equal to 2. All right, if that blue dot was not there, if that blue dot was not there, then we would say that this did not exist. All right, because you cannot say that it equals infinity. A function will never equal infinity. Infinity is a concept, not a value. So limits are allowed to go to infinity, but function values are never allowed to equal infinity. All right, so one more. All right, so our last one for today. How about all of you hit pause, try to do all of these on your own, and then take a look at the video. All right, so let's see how everyone did. Here is our crazy piecewise defined function as a graph made up of multiple pieces, and then here's everything we need to take a look at. So let's go left to right first, starting at -4. The limit of f of x as x goes to -4 from the left. 1, 2, 3, 4. So here's the x value of -4. As we get really close to x equaling -4 from the left, we're getting really close to that y value of 2. Then let's take a look at the limit of the function as x goes to -4 from the right. Here's again -4s. We're getting really close to it from the right. We're coming up along here, getting really close to that y value of 2 again. So the left limit was 2. The right limit was also 2. So overall, the limit of f of x as x goes to -4 is also equal to 2. If we took a look at the graph, our fingers do come together. There is that hole, but our fingers were getting really close to each other. So the limit of where they were getting really close to was 2. What's the value of the function at -4? The value of the function at -4 is actually just 0. All right, so the function does not always have to equal the limit at that value. Next, let's move along to -2. Here is x equals -2. Is we do the limit of f of x as x goes to -2 from the left. That means we're going all the way down here. Looks like we're not going to stop. So that limit's going to be -infinity. The limit of the function as x goes to -2 from the right. Again, here's -2 coming at it from the right. We're going down. Looks like we're not going to stop. So that limit is also -infinity. Then the limit of f of x as x goes to -2. The left limit was -infinity. The right limit was -infinity. So overall, the limit of f of x as x goes to -2 is also -infinity. What's the value of the function at -2? The value of the function at -2, we do have that dot right in there. That dot at x equals -2 is also at the y value of -2. So the function is equal to -2 when x is -2. Again, if this was not here, if that was not there, if that dot was not there, we would not have this as an answer. We would say instead that it does not exist, because we can never say that a function can never equal infinity. All right, infinity is a concept, not a value. So a function cannot equal infinity. The limits are allowed to equal infinity because that's the limit of how big it can get, infinity or negative infinity. Functions themselves can never actually equal infinity. All right, moving on to 0. As we go to 0 from the left, here's x equals 0. 0 from the left, we're getting close to the y value of 0. 0 from the right, here's x equals 0 again. As we get really close to x equaling 0 from the right, we're actually getting close to this y value up here. 1, 2, 3, 4, 5. Limit from the left was equal to 0. Limit from the right was equal to 5. 0 and 5 are not equal to each other, so this limit does not exist. Graphically, tracing, my fingers have not come together. Does not exist. What is f of 0? Again, here's x equals 0, open circle, closed circle, so 5, where the closed circle was. Let's move over to 3. Do the limit as x goes to 3 from the right. 1, 2, 3. Sorry, from the left. We're going from the left, from the left, from the left. As x goes to 3 from the left. Here's 3, coming at it from the left. We're getting really close to this y value here, which is -3. As x goes to 3 from the right, here's our x value of 3 from the right. We're getting really close to that y value. Again, -3. Left limit was -3, right limit was -3, so the limit of f of x as x goes to 3 is also equal to -3. And then what's the value of the function at 3? We do have x equals 3. We do have that filled in dot right there, so that is also equal to 3. All right, so that is it for today. I salute all of the hard work that you've been doing in all of your classes and everything that you're doing at home with your families as well. Keep everything moving forward. So stay safe, and I will see you soon.